Hello, my name is Raul Rahimli. I'm first grade student at ADA University. And today I'm going to solve the question number 808. The question says, find the indicated limits of functions in the following examples. So our limit is like this. So firstly, we have to check whether this is indeterminate function or not, indeterminate limit or not. So we're going to write limit x approaching 0, cosine x over sine x, power of sine x. So it's going to be limit x approaching 0, 1 over 0 power of 0. So it's going to be infinity over 0. It's an indeterminate form, infinity over 0. So now we can solve it. So now what we can do, as we see, here is sine and here is also sine. So we can make a formula which is limit x approaching 0 sine x over x is going to be 1. So let's make it. We will make grouping. So limit x approaching 0 cosine x over, let's write x multiplied by sine x over x, power of x multiplied by sine x over x. So in this situation, here and here we are going to it's going to be 1. So our function will be, our limit is going to be limit x approaching to 0 cosine x over x, power of x. So our final version is like this. Yes, I will erase this because there is no space for writing cosine x over x over x. Yes, finally we got limit x approaching 0 cosine x over x, power of x. So in this situation, what can we do? We can write the formula like using the formula a power of x equals to e power of x ln a. We can write. So it's going to be limit x approaching 0 e power of x ln cosine x over x. So it's better for us to use sine because we can use the previous formula. So here we are going to like use the common formula sine square x. Let's write not x over 2 equals to, so 1 minus, sorry, 1 minus cosine x over 2. So here we are going to have 1 minus cosine x equals to 2 sine square x over 2. So here minus cosine x equals to 2 sine square x over 2 minus 1, and cosine x is going to be 1 minus 2 sine square x over 2. So we can replace cosine x by this. Yes. So here we are going to have, let's erase this part. So we got 1 minus sine square x over 2. Yes. So our final version is going to be limit x approaching 0, e power of x ln, so 1 minus 2 sine square x over 2 over x. We are going to put here negative sign, so let's write it like this. Let's write it again. So it's going to be limit x approaching 0, e power of x ln negative 2 sine square x over 2 minus 1 over x, in order to make it easier. So at the end we are going to have limit x approaching 0, e power of x ln, and it's going to be, so we are going to apply the first formula, sin x over x equals to 1 when limit is approaching to 0. So here we are going to add, it's going to be negative 2 sin x over 2, we will divide by x over 2, it's going to be squared. Sorry, it's going to be squared because here is square, and we are going to multiply x squared over 4. Then we are going to subtract 1 and divide by x. So our final version is like this. So let's divide. Let's divide here. Here it's going to be 1. So it's going to be just limit x approaching 0, e power of x ln, it's going to be x squared minus 1, x squared over 2 minus 1 over x. So here we can make them denominators equal, denominators. So it's going to be e power of x ln x squared minus 2 over 2 x, let's say. So x is going to here and also like this. So the final version is like this. Let's erase all of this stuff. So what was our final version? It was like this. Okay, limit x approaching 0, e power of x ln x squared minus 2 over 2x. It was our final version. So we're going to make something else. So we're going to use the formula of exponential limits. So it's going to be limit x approaching a when fx power of gx equals. So it's going to be limit x approaching to a, fx power of limit x approaching to a, gx. So it's our formula. So we are going to find firstly this one, then this one, and then put the power for both of them. So our fx, so limit x approaching to 0 fx, is going to be limit x approaching to 0 e, which equals to e. Actually, limit fx we found it's e. It was easy. So we are going to find gx, which is this part. So let's erase everything.